Okay, so this is going to be a little overview of the compound naming review. I wanted to make sure that you understood what you're supposed to do in each section. So I'm going to do the first one of each section with you so that you kind of have an idea, and then you can do the rest of them on your own. So the first little section is the polyatomic ions, and it says using your chapter 9 notes or flashcards, write the formulas for the following. So number 1 there says nitrate. Well, if we look at our flashcards, or if we look at 9.1, nitrate is NO3 with a 1- charge. You can't just put NO3 because that is not nitrate. It has to have that negative charge in order to be nitrate, okay? So go ahead and do the rest of those polyatomic ions. Second section says diatomic elements, names, and diatomic element formulas, okay? Well, I'm gonna give you one of each just so that you kind of know what we're talking about there. So for the diatomics, one of the diatomics is hydrogen. Remember, anything that ends in gen is going to be diatomic, and then anything that ends in ene is diatomic. And so there's 7 really that are common that you're going to be able to find in your notes, okay? But at least 7 you need to get written down. 3 gens, 4 enes, okay? So that would be the name, and then the formula for it, because it's diatomic, is H2, not just H. So whenever you see hydrogen written in a chemical equation, it's talking about H2. All right, simple anions, sulfide. Remember, with anions and cations that are simple, meaning they're made out of only one atom, okay, we're going to take the element and we're going to figure out what charge it was based on where it is on the periodic table. So sulfide, remember ide comes at the end of the name. When we change it after it's become negative, so sulfur is sulfide, and it's 2 away from being stable, so it's going to gain 2. It's going to have a -2 charge. So for the anions, number 1 is S2-. Sulfur becomes sulfide when it gets that -2 charge, okay? Okay, simple cations. Number 1 for the cations is sodium. Please use your periodic table. I'm getting a lot of people putting S's for sodium. Don't do that, okay? And I'm getting a lot of people putting P's for potassium. Remember, potassium's a K. Always find it on the periodic table. Just look for it, okay? So sodium is Na. Again, not a straightforward symbol for sodium. It comes from its Latin name natrium. But when it's a cation, remember group 1, they all have 1 valence electron. So to become stable, they lose it, which gets them down to that full layer underneath. So sodium becomes a 1+ ion by losing that electron. So Na, 1+. Remember, when we have 1s, we don't necessarily need those. If we had NO3- or Na+, both of those would work. I usually add the 1s just to be really straightforward and clear. And then at the bottom, we've got practice writing the formulas for compounds. Remember, compounds like number 1, number 2, number 3, number 4, number 5, all of those you have to think about, what is the cation, what is the anion, how do I balance them? 6 and 7 are straightforward. They tell you in the name what the ratio of the atoms are because they're covalent. But number 8 is one of our diatomics. So don't forget, anything that ends in gen is going to end up with a 2 in its formula, okay? So do all of the rest of them, including those formulas for the bottom compounds and elements, and then submit it. Try your best, but really we kind of expect you to get these right. So let us know if you have any questions, if you're struggling, and we will see you in class.